Welcome to the module focusing on the security of data. In this module, we'd like to think about why ensuring and maintaining confidentiality, integrity, and authenticity of data should be the main purpose and role of computer security policies. Let's start by reaching back to the essence of this problem. Why does computer security usually fail against attacks? The reason is that system users are often unaware of the threats they're facing. And if they're unaware, they can't counteract the threats. The second aspect of data security that relates both to users and administrators is a failure to clearly identify the resources that require protection. There's a common thinking pattern that pictures a safe computer network separated from the big bad internet with a firewall. This has been outdated for some time now. You can't base your security policy on this type of assumption. One problem that relates only to computer systems administrators is their unchecked belief in technology. We tend to think subconsciously that since we've paid a lot of money for security solutions provided by a popular brand, they'll be completely reliable and efficient. If you don't know the mechanisms behind a solution or technology, or don't even know attack vectors, running a piece of software or a tool won't make you secure. Users and administrators need to keep track of new developments and utilities in the system security field and deal with threats differently than is shown in the slide. Why is this all so hard? The main reason for this difficulty is a new growing trend known as the consumerization of IT. The tables have turned since the development of high-tech software and devices. In the past, new technologies were enterprise-led and only after time emerged on the consumer market. Devices were customized for the needs and goals of businesses. Today, there's no recognizable boundary between consumer and corporate technology. Appliances and software are being designed with users in mind. What are the effects of this reversal? It's harder to say whether the smartphone you're holding is a company device or a private device. The same technology can be used at work and for play. It wasn't quite this way a while back, and this shift seems to have blurred the lines between business computer systems and home systems. New developments mean that more and more people can work from home, and we use our own devices, a laptop or a smartphone, for work. System administrators have limited control over these devices, if there's any control at all. Administrators can't force us to stop using our own devices because our productivity would be lowered. We can do some tasks remotely while traveling or on holidays. Companies can't ban sending emails from outside their offices. While this would improve security, it just simply isn't feasible. Given this new emerging reality, IT security staff have to reformulate their strategies and actions. A good solution for this problem was introducing a new term. It's ridiculous to say that our security measures are ineffective because script kids launch exploits remotely. Advanced persistence threat has a different ring to it, though. Saying that we can be susceptible to threats that are advanced and persistent is not equivalent to an admission of guilt. APT was coined and defined in 2006 by the US Army, when the military began to realize that existing computer security models were ineffective. Funds on fighting launched attacks were irrationally high compared to the results. Something had to be changed. Originally, APT referred to persistent threats, or those threats that were a long-term risk. A good example of persistent activity is the slew of attacks on American high-tech companies that were detected by Google and occurred from 2006 to 2007. In this attack, email boxes of the company's staff had been monitored for over a year. Today, advanced persistent threats are understood as attacks that successfully launch malicious software on targeted computers. Malicious software is a broad term. We'll show you why launching a program can cause an attacker to take over a system. Local attacks and large-scale attacks that exploit vulnerabilities in security systems. We'll talk about this vector in the following modules. By and large, advanced persistent threats include internal attacks. For the most part, internal attacks render any technological protection measures useless. The last category of threats classed as apps are the attacks that target trusted communications channels. The amount of information exchanged between computer systems is huge. Intrusion detection systems implemented in banks and insurance institutions often react only to active suspicious user actions. Attackers exploit a tendency of specialist IDS tools to react to unauthorized claims payments, but ignore information extraction. In protecting data, it's crucial to set up goals that you want to achieve. Our first objective should be the confidentiality of data. Confidentiality means that data is safeguarded against unauthorized access. Information should be categorized according to its sensitivity. It doesn't make sense to take measures for protecting information that's published online on a company's website. Any company will understandably be happy that there are visitors on the website. Internal information is the second class of information. This category of data is available to a broad group of selected people, for example, for all the employees in a company. We wouldn't want unauthorized persons to access this type of information. But it doesn't spell the end of the world if a breach occurs. The next category of information includes personal information. Personally identifiable information is defined as information that can be used to easily and specifically identify a person to whom the information relates. National identification numbers like social security numbers are an obvious example of personal information. There's also sensitive data. This class of data, if disclosed to the public, brings direct losses to a specific person. The last data confidentiality category includes classified information. This is a type of data that should only be accessed by trusted people. Disclosing classified information deals a grievous blow to a company. Assigning a level of sensitivity to data stored on a system fast-tracks the implementation of a data security policy in a company. If a company fails to introduce this policy, this could end in the sort of situations you've seen in previous modules, where you can view classified, sensitive, and confidential information on the internet next to people's personal information. Confidentiality of data has to be protected in some way. In the past, obtaining or extracting confidential data was a difficult feat. The next time you see a person go through the garbage bins of your company, remember that the person does not have to be a beggar in search of food. In the US, the trash that's located in a company's site belongs to that company. Trespassing and stealing things from trash bins is illegal. The contents of the bins only later become public property. It's increasingly easy to find confidential information on the internet. Let's see how this can be done. To do this, we'll use a hacking technique that most of you know very well, Google hacking. We'll see if Google can be used to find some information on people who interest us. We'll also find out if it's true that once a piece of information is put on the web, it will exist there forever. Finally, we'll also use specialist programs like FOCA to automate the process of finding information. Let's start with a question. Is it possible to completely erase a piece of information that has been published online? To find an answer, we'll use a site called archive.org. There's a time machine called the Wayback Machine available on this site. Let's type in any address you're interested in, for example, Microsoft.com, and click on Take Me Back. After the search ends, you'll be able to view the archived versions of the page. Let's start with 1996. There are only a few copies of the page from that year. Let's see how the website looked on October 29, 1996. We have a chance to take a peek into the past and see how the page looked in 1996. All links on the page are related to one another and are still active. You can read press information about Microsoft from 1996. What's been put on the internet stays on the internet forever. Let's check now if a popular search engine like Google will enable us to find confidential information on the internet. I have a few predefined queries which you've already seen on a slide. We'll start with exploring whether there are any results for company XLS spreadsheets, in other words, Excel spreadsheets, that relate to user accounts. It'd take a lot of time and persistence to browse through all of these spreadsheets, but I'll try to give you a more interesting example and show another type of search. This time we'll search for PDF files on military websites that contain the phrase top secret. It doesn't seem likely that anyone would put these documents on the web, does it? But here you are. If this piques your interest and you're not planning on visiting any of the countries that put up these files, go ahead and click on the links to find out what types of classified information can easily be found on the web. The crawling methods I've shown you are manual. They can be automated though, for example by using a tool like Gulag Scanner. The application contains a simple set of Google queries that fall into several categories. There are, for example, video files containing juicy info like passwords, logins and the like, or software errors messages that display sensitive information on a system. Another category includes files containing usernames. Clicking on Open in the browser will cause a search engine with selected file types to be displayed. Instead of clicking on each file type, you can select a whole category. Type in a page name that interests you, for example, example.com, and click on Scan. Notice that you don't connect to the site directly. We don't search for information on the servers of a given company. The query is not only sent to the Google search engine. We're exploring what has already been indexed. We'll be able to send bulk queries until search engines like Google block them. As you can see in the slide, 15 results have been returned. All queries have been processed successfully, which means there are no files that contain usernames in the results. A small application called FOCA is a rather curious example of a search engine that crawls the web for publicly available information. It enables users to not only analyze selected websites, but also the metadata that's saved in the website files. We'll create a project by entering a website name, for example, Microsoft.com. Using search engines like Google or Bing, we can try to extract information on the network infrastructure, the servers, versions, and so on. We can try to ascertain whether or not there are any vulnerabilities or susceptibilities to a given type of threat. We can also read the metadata, or the various documents. Opening the documents will extract information on their creators. To download an analyzed file, right-click on the document and select Download. Once you've downloaded the files, they can be analyzed. Click on Extract Metadata. We'll extract all the metadata available for the document. Files from both categories will be analyzed in sequence. We have records for 10 users. They're the creators of PDF documents or doc files. We can view the information on when and in how many documents they used OpenOffice and Microsoft Office, and also see the versions of the operating systems that were used to create the documents. All this metadata is contained in the files that we edit and save on a daily basis. When you publish your files on the internet, you have to realize that the metadata will also be published and be accessible. Metadata discloses not only the information on a configuration of the system, but it also contains your personal information. FOCA is a great tool for extracting information of this type. Thus far, we've talked about data confidentiality. This is the most relevant aspect and the first thing that springs to mind when data protection is concerned. But this doesn't always have to be the case. Sometimes the integrity of data is equally important. Data integrity refers to a situation when a given message has not been modified by an unauthorized person. Data integrity can be maintained by adding specific checksums to the data. This method also helps protecting the integrity of operating system files. If a document you open has a different checksum than that of a document saved by a trusted user, this points to a data integrity corruption. Why is integrity so important? Let's use online orders as an example. If someone has spied that we've ordered 5 books, this usually doesn't bother us. But if that person modifies the order value from 5 to 500 books, we would be less than happy. Integrity is a vital feature of information. Data authenticity is another key aspect to data security. Authenticity is a bit broader in scope than integrity. Authenticity is a feature of information that ensures that the sender of the data stream is legitimate and that the data has not been modified after it was sent by a trusted sender. This feature can be verified through the use of digital signatures. We'll cover this in coming modules. As we've stressed before, you should not put too much faith in technology. You can see an example of why limited trust is the best option. It's a certificate for signing crucial information contained in system files, or EXE files. It was stolen and used to sign malicious software. Authenticity is verified through digital signatures on files that are usually generated from certificates. A certificate has an assigned level of trust a user can give. The last feature of information is its availability. Data availability is specified in an SLA, Service Level Agreement. IT departments and business customers are bound with the terms and conditions of an SLA. The specifications of this contract define the maximum tolerable lengths of service unavailability and determine the amounts of information that can be lost after a disaster. You can find lots of information on SLAs on the internet. The key elements of the agreement are Recovery Time Objective, RTO, which is the duration of time in which a service can be unavailable, most often calculated in a percentage. The closer to 100%, the longer the information needs to be available. Recovery Point Objective, RPO, which is the amount of data that can be lost in the event of a failure. The Recovery Time Objective forms the foundation of all SLAs. The measure is the non-negotiable duration of time within which information or services can be unavailable. It is usually expressed as a number of nines. If a given service is to be provided 365 days a year, 24 hours a day, 7 days a week, this means that an RTO value that has 5 nines, 99.999%, can only be shut down for whatever reason, maintenance, attacks, threats, for 5 minutes in a year. Agreeing on a 5 nines RTO means that a given service or information has to be protected in a special way. It's impossible to provide an RTO this high if data is stored in one system only. Hosting companies usually agree to a 4-digit RTO. Under the same assumptions, 3 nines mean that a service can shut down for 8 hours per year maximum. You can't expect your only computer to be set up for the whole year without interruption. And 8 hours will probably be too little to successfully deal with an attack or to restore a system after a failure. Another part of an SLA which is defined in all contracts of this type is a Recovery Point Objective, which is the measure that determines the amount of data that can be lost after an attack. It's easier to ensure a recovery point objective of 0%. It's a matter of replicating data and creating backups than to ensure an RTO equaling 99.999%. In the case of the RTO, high availability comes with the need for investing in expensive equipment. SLAs are becoming increasingly popular, and it's quite possible that you'll often be asked to sign an SLA that determines the RPO as a 0%. Businesses need the guarantee that whatever happens, no data will be lost from the system. We have few technologies that can ensure implementing good values of RTO and RPO. We'll mention them later on in the next modules of this course. High availability of services usually require the use of specialist technologies that will also be covered in the next part of this course. Thank you.